So, hello students, welcome back. Today we are going to understand spectroscopy and especially a very main topic, that is NMR numerical based on NMR splitting. So, this is an important topic which is asked in most of the entrance exams like SET, NET, JEE, GATE, and even it is in your BSc course. So, let us start. I always hear the students saying, I just don't know, and just don't understand how the splitting takes place in NMR spectroscopy. Oh my, it's so difficult. So student, just wait. Let us understand and let us study together how the NMR splitting takes place. So are you ready to dive in? So in this we will be seeing basic concepts of NMR spectroscopy, NMR signals and splittings. Then we will be seeing the relative intensities of NMR peaks, what is NMR spectrum, and the numerical based on NMR splitting. So let's begin. So first of all, let us understand what is NMR spectroscopy. So basically NMR. So N indicates nuclear, M indicates magnetic, and R indicates resonance. So basically NMR is nothing but nuclear magnetic resonance, or it is also known as proton magnetic resonance, which is known as denoted by PMR. Okay, so NMR spectroscopy is just a technique which is used or which is useful to find out the basically the signals of protons or any nucleus which is going to have a magnetic property. Okay, so let us understand now what is NMR actually. So NMR is a technique that uses magnetic property of an atomic nuclei to study the molecule, providing information about their structure, dynamics, and chemical environment. So here the atomic nuclei actually behaves like a tiny magnet. So let us understand with these atoms which I have shown here. Okay, so if you see these atoms, so there is one atom where I have shown the arrow upward, and the other atom which is shown arrow downward, and these both the atoms we are placed in the magnetic field, external magnetic field. So I have shown that external magnetic field upward direction, which is denoted by B0, and these atoms have nucleus. So these atomic nucleus actually possess magnetic moment due to their spin. So we know that these they are going to spin one in clockwise direction. Okay, this, let us understand that this is moving in a clockwise direction and this is moving in an anti-clockwise direction. So there will be, suppose that we have taken number of molecules and there are number of atoms present which are all placed in the magnetic field. Now all these atoms which are placed in magnetic field, there will be few which will be in the same direction, that is in the direction of the magnetic field. Okay, so there are many other atoms which are in the same direction, moving in the upward in same direction of magnetic field, but there will be few which will be opposing the direction of magnetic field. Okay, so those who are in the same field or same direction of magnetic field which is applied, that is this external magnetic field, external magnetic field. Okay, external magnetic field, you will find that they can move easily. But those which are in which are opposing the magnetic field, like here this one, it is going to have higher energy because it is opposing the direction of the flow of the energy from outside. So these atoms or these nuclei will have high energy as they are going to oppose the force external magnetic field, whereas these atoms which are in the same direction of magnetic field will have, or they are aligned in the same magnetic same direction of the magnetic field, they will have low energy. Okay, they will adopt low energy, and this way these nuclei, they are going to show some we can say they are going to show some information in the form of signals in the NMR spectroscopy. So basically the magnetic property of nuclei, that is due to its spin, because of its spinning, when they are placed in the external magnetic field, these nuclei align themselves with the field, adopting either low energy like this one. So this will show a low energy, it is going to adopt low energy, whereas this which is opposing the direction, opposing the external field, is going to adopt high energy, as it is opposing the direction of external magnetic field. Okay, so NMR active nuclei, which nuclei can be active in such external magnetic field? Not all nuclei are active. Only those nuclei such as proton, which is having one electron, then your deuterium, carbon 13, nitrogen 15, these are the NMR active nuclei, behave like a tiny magnet, capable of aligning with the external magnetic field, and this process is called as magnetization. Okay, so basically you should understand only those nuclei which are going to align themselves in the external magnetic field, or can produce magnetization, are going to be active nuclei, and which can show some signals in NMR spectroscopy. So which are those nuclei which can show signals in NMR spectroscopy? Those are proton, deuterium, carbon 13, nitrogen 15, and so on. So you can see here, I've shown here how the electron is, the nuclei is spinning. So now let us understand NMR signals and its splitting. In NMR spectroscopy, the signals we see don't always appear in as a single piece as it is shown here. Instead, they often split up into multiple peaks. So even though here we can see only one single peak, but they may be having multiple peaks if you go for high resolution. Okay, this happens because hydrogen atom or a proton in molecule can talk to their neighboring protons through some type of spin-spin coupling. So basically what is happening is these protons or hydrogen in the organic molecule are going to have some interaction with the neighboring proton. So children, you have to always keep this in mind, that NMR spectra where we are considering HNMR indicates proton NMR. Okay, so here the nucleus of proton we are going to consider. So in HNMR what happens is that the proton nuclei is going to give you the signals. So here the proton atom in a molecule has some interaction with the neighboring proton, okay, which is called as spin-spin coupling, which is known as spin-spin coupling. A simple trick to predict how many peaks a signal will split up into, there is a rule. That rule says it is n plus 1. Okay, so simple formula you have to remember, that is n plus 1, to know whether the signal is going to split into different peaks or whether you will have one single peak or one single signal. Okay, so just count how many neighboring protons there are, which will be indicated as n. There is a simple trick what you have to do. You have to just find out how many neighboring protons are there. Okay, and add 1 to that so that you can get the number of peaks. So it is so simple. What you have to do, suppose you are talking about one first one proton, and this proton you have to see how many neighboring protons are present. Okay, how many neighboring protons are present, and you have to just suppose there are 3 protons in the neighboring, then it will be 3 plus 1. So the formula says you it is n plus 1. So 3 plus 1 means 4. So in one signal you will find 4 peaks. Okay, so let us see the with example so that it will make this concept more clear. So let us understand with the example, and the example here we are going to see is, it is ethane. Okay, so ethane, you know the formula is CH3CH3. So if you count the number of protons in ethane, there are total number 6. Okay, 3 on first carbon and 3 on second carbon. So total hydrogen on or proton or ethane are 6, which are attached to 2 carbons. First carbon, let me write here, it is first carbon and second carbon. So first carbon you have 3 protons and second carbon you have 3 protons. Now both the protons are identical, as this carbon is having the same environment like this carbon. So let us write the structural formula for ethane. So here you can see on the screen, it is CHHH CHHH. So all 6 protons we have shown here in on the ethane molecule. And if you see the, let us understand like this, first proton, okay, this proton, if you see this proton, it has same surrounding, it is surrounded with the same number of atoms everywhere. Means on the right hand side it has one proton, then carbon, then hydrogen, here also hydrogen. This proton is directly attached with the carbon, and it is attached with the hydrogen and then proton. Similarly, if you talk about this proton, it will be similar to the first one. Okay, so let us label this as second proton, this is first proton. So if you see the surrounding of this proton, again it is attached with the carbon, then hydrogen, means the carbon is attached uh, to the hydrogen. Similarly, means first bond, second bond is again with the carbon, then hydrogen. So if you see for each and every proton, it is in a similar fashion. Now if the third proton, if you talk about, it is directly attached with the carbon, that carbon is attached to the next carbon, which is attached to 3 more protons. So let us talk about this proton. This proton again, similarly it is connected with carbon, first carbon, then second carbon, and 3 protons. So here if you talk about all, if you try to see all the protons or all the hydrogens, they have same environment. Same environment means how they are attached to one another. Okay, so environment is same for every proton in this ethane. Now when the environment is same for every proton in ethane, we call them as equivalent proton. What we call such protons? Such protons are known as equivalent protons. Okay, so here you can find in the statement we have written that since all the hydrogen atoms are chemically equivalent, that means they experience the same environment. They do not split each other signals. Means if all these protons are having same environment, then they do not split. Okay, they do not split, and that's the reason why in the graph or in the spectrum, this is NMR spectrum, NMR spectrum. So in NMR spectrum, you are going to see only one peak or only one signal. Okay, this is one signal which you are going to see in the spectrum, because all the protons are in same environment, and that's the reason why we have labeled them all by same letter, that is A. All 6 protons you can see I have labeled them by A. So all are, that A indicates what? All are chemically equivalent protons, and that's the reason why in HNMR spectrum ethane shows only single peak or singlet. It is called as singlet because one single line will be known as singlet. Singlet indicates that there is only one signal which you can see in the spectrum. Okay, because all the 6 hydrogen atoms are equivalent, and there is no neighboring non-equivalent proton. Non-equivalent proton. Now you can understand what is equivalent and non-equivalent. Non-equivalent proton means the environment is different. Okay, non-equivalent proton means the environment is different. So if there is same environment, then we call such protons as equivalent protons. If the environment is different, we call such proton as non-equivalent proton. And if non-equivalent protons are present, then they split the peak. They split the signal. Okay, here there are no, in ethane there are only, all the protons are equivalent, so it is not going to split the signal. So let us understand this better with the next example. Okay, before going to the next example, how the splitting takes place, let us understand the n+1 rule again. So what is it? N+1 rule? N+1 rule helps us to predict how many peaks or splittings we will be getting. Okay, we can see in the NMR spectroscopy. So n+1 only tells you how the signal is going to split up. So this splitting actually takes place, you can see it in the high resonance. In low resonance, we can only see the signals. Okay, so there are two things we have to understand. One, the splitting, and one, whether the signals are in low resolution or whether the signals are, we are seeing it in the high resolution. So that when we see the examples, this concept will be clear. Now one by one, let us understand. Count the number of hydrogen atoms or protons on the neighboring carbon. So first thing what you have to do, try to count the number of protons on the neighboring carbon. Then what you have to do, suppose there are two neighboring protons, then add 1 to it. So 2 plus 1, it will be 3. So see how the splitting takes place. You can see this table. It is also, splitting is also known as multiplicity. So if the neighboring proton, which is indicated by n, is 0, then according to rule it will be n+1. So only one signal will be there, and that one signal, we will have only one peak. Okay, one signal is there and it will have only one peak. So one peak, then we call it as singlet. Then if the carbon has one proton and it has a neighboring proton, means that carbon has one more neighboring carbon and which has only one proton, then the rule is what? 1 plus 1, which is 2. Okay, so neighboring carbon, if it has only one proton, then it will be 1 plus 1, that is 2. Means the proton is going to show a doublet. 2 indicates 2 peaks, so it will show doublet. If the neighboring carbon has 2 protons, then it is 2 plus 1, 3. So it will be known as triplet. Triplet indicates 3 peaks. Similarly, next, 3 plus 1, you will have 4, which is called as quadret. That is 4 peaks. Then if the neighboring carbon has 4 protons, now you may wonder how 4 protons are there in the neighboring. So with examples we can understand this. Key, one proton can have 4 neighboring protons also. Okay, 4 proton plus 1, that is 5, that is quintet. So 5 peaks. And if it is a sectet, that is 6, or hextet also it is said, which is 6 protons, 6 peaks, that means 5 neighboring protons are there, 5 plus 1 is 6, and so on, you can go on. Okay, so this is how the splitting takes place, and the names are given for the splittings or type of splittings, that singlet, doublet, triplet, quadret, and so on. So let us see the NMR spin coupling or splitting. So in the high resolution, as I said, that we will be studying the peaks in two resolution. One is low resolution and other is high resolution. So in a high resolution, the signals will be split up in the peaks which are shown here. So if neighboring carbon has one proton, then we are going to have 1 plus 1, that is 1 plus 1 2 means doublet. So the signal you can see it in this fashion, that is doublet. Doublet means two peaks you will be seeing. Triplet means you can see the signal as three peaks. Okay, now if you see the peaks, there is some way I have drawn the peaks. Okay, all peaks are not having the same height or same intensity we call. Okay, these, if you see, some are short, some are long, some are short, some are long, whereas in quadrate you can find there are two peaks which are having same height and the middle two are having the same height. So the height indicates the intensity of that proton or the signal. What is the intensity of that signal? Okay, so let us understand that with the help of one triangle, which is called which we are going to study using this triangle, the relative intensity of the peaks. So whatever peaks we saw in the previous slide, that those peaks, that is singlet, doublet, triplet, quadrat, quintet, these will be having some intensity. Like singlet, it has only one single line will be there in the signal, so it will have only in the these whatever I have written here, these are the ratios. Okay, ratio it is. So singlet will have one single line and with a full intensity. Then doublet is, suppose the intensity is 100, we consider the intensity as 100%. Okay, if the intensity is 100%, then the first signal, that is singlet, will show complete 100% signal. Then doublet, if the complete intensity is 100, doublet means it will get divided into 1:1. So 100, if we divide it into 1:1, it will be 50:50. So 50 means half, that is 1:1. Okay, 1:1. So you will see two signals which are having equal intensity or equal height. Then triplet means the intensity is 1:2:1. Okay, triplet, what it shows in the triangle, it is 1:2:1. So 1:2:1 means 100 you have to divide in such a way that you will get one intensity, its double intensity, the middle one, and then again one. So 1:2:1 it is called. Okay, that means what? If this is 25, the middle one should be 50 and then again 25%, this way. Then quadrat, if you have a peak which is 4, because quadrat indicates 4 peaks, then the intensity will be 1:3:1:3:3:1. Okay, so here the peak will be in this fashion. Suppose one indicates 10 centimeter, then the next peak will be 3 times of the first peak. Okay, it will be 3 times of the first peak, then again 3 times, and then 1 time. Okay, this way the peak way you can see the peaks in the spectrum. Quintet means, quintet will have the intensity as 1:4:6:4:1. So again, as I explained, one, whatever is one part, its 4 part will be your next peak. Then 6 times the first peak, whatever is your first peak, it's 6 times, then again 4 times, then 1 time. And this way you can see the signal in your NMR spectrum. Okay, so I think this is clear to everyone. Now you will wonder, what is this, how to remember this peak, or how to remember these intensities for singlet, doublet, triplet. Okay, so it is very easy, because the triangle which we have drawn is known as what? It is known as Pascal triangle. It is known as Pascal triangle. So this Pascal triangle, you can just draw first one triangle, and first layer we will number it as 1. Okay, second layer there will be 2 boxes which will be 1 1 again. Then the third layer will have obviously 3 boxes as shown, but then how to remember it? The corner or the extremes will be always 1, and the middle you have to just add the previous 2 blocks just before it, that is 1 plus 1, it is 2. Then next row or next layer will carry 4 box, and as I told you, the extremes will always have 1 denoted by 1. Then this box will be addition of these two. Okay, 1 plus 2 is 3. Similarly, this box will be addition of 2 plus 1, that is 3. The next layer you will have total now 5 boxes. Okay, in 5 boxes the extremes will be 1. Then the next one will be 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1, and so on. You can just go on. So now 5 we have already done for quintet. Now let us see for 6. Now for 6 it will be 1, 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and 1. Okay, now let us see for 7 layers, that is 7 boxes. Now for 7 boxes, 1, 2, 3, 4, 5, 6, 7, yeah. The extremes will be again 1. 1 plus 5 is 6, 5 plus 10 is 15, then 20, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and 1. So this will be for 7 peaks. Okay, this is for 6 peaks, 5 peaks, 5 peak, 4 peak, 3, 2, and 1. So you can just go on increasing depending on how many neighboring protons are there, and this way your peak intensity we can calculate. Okay, so this triangle is known as what? Pascal's triangle. Pascal's triangle. Okay, so using Pascal triangle we can find the relative intensity of the peak. I think this is clear, student. So this is the Pascal triangle. Now let us go to the next. So Pascal triangle, what it does? Pascal triangle and peak intensity. Each row of the Pascal triangle tells us the relative intensity of the peaks in NMR splitting. So let us see one by one. Now 1:1 ratio, doublet. Singlet, it will have only one full intensity. Doublet, which is denoted by small d, singlet is denoted by small s. So doublet indicates that there are two peaks which are in the ratio 1:1. Then triplet, it will have 1:2:1. Quadret, which is denoted by small q, 1:3:3:1. Quintet, which is denoted by q, that is 1:4:6:4:1. Then hextet, 1:5:10:10:5:1. Okay, which is denoted either by s. Then basically after quadret, if we have multiple peaks, we call it as multiplet. And it is denoted by small m. Okay, multiplet indicates more than four peaks. So you can, even for hextet also you can write m, like I have written here septet m, because m indicates multiplet, more than 4 peaks are there. So in septet, as we have seen, 1:6:15:20:15:6:1. The peak intensity will go on rising in this fashion. Okay, so that is what about the intensity of peaks. Now this is how the NMR spectrum look like. So when you place the compound in NMR spectrometer, what is going to happen? You on the screen you will find a spectrum. Now that spectrum will be depending on how many protons and which environment the protons are present in that molecule. Okay, so in low resolution you can see only single line. Suppose this whatever I have shown here, we are seeing this in low resolution. Okay, in low resolution we are seeing this spectrum. So you can see only one single line. So there are two signals. So what we will call for such spectrum, in low resolution we can see two signals. So these are called as signals. Okay, these are known as signals. There are two signals, but the same molecule, if you put it in a high resolution, then the spectrum you can see the fine splittings, that is peaks. Suppose this is having, this signal was split up into triplet. Why triplet? What does triplet indicates? If this signal was if under high resolution, if you see that the peak was, this peak has split up into three peaks. Triplet indicates three peaks. So you will find some very nice fine peaks. Okay, this one, if I see it in a high resolution, suppose this is high resolution, so one single peak you can find it in this way. Okay, this fashion. They are very close, very finely close to each other, and you, if you try to uh, have a high resolution, then you can find those peaks. Okay, so what does triplet indicates? The triplet indicates that the proton has neighboring two more protons. Triplet indicates what? N plus 1. So n plus 1 is 3, means n becomes 2. So this proton, whatever is the proton which is showing the triplet, is having neighboring two more protons. So two more protons will show triplet. Okay, so let me now make you understand how these peaks are denoted and from where to where it is. Delta is equal to 0 is your starting point. So delta is 0 is your starting point. Delta indicates what? Magnetic field strength, that also in parts per million. ppm indicates parts per million. So your spectrum will be from 0 to 10. Delta is equal to 10. So this is always from 0 to 10, and the graph is, or the spectrum is, intensity versus magnetic field strength. Okay, so whatever is the height of the peak, it indicates what? It indicates the intensity of the peak. Just now using Pascal triangle we saw what are the intensities of the peak and how they are. Okay, so here on y-axis you will find it is intensity, on x-axis it is magnetic field strength. So this way the NMR spectrum we can see on our display. Now if delta is equal to 0, it indicates upfilled. We call it as upfilled. Means if any proton which is showing peak here, this side, so we call such protons as upfilled protons, or they are also called as shielded proton. The word shielded is nothing but shield. Shield means protection. So these protons are protected. Okay, so those protons which are, or those hydrogens which are protected one, will always show the signal upfilled, that is towards 0. Upfilled indicates delta is equal to, means they are towards the 0. So which protons will show uh, the signal towards 0? Those protons which are shielded one. Shielded means protected one. Now those signals which we are seeing towards 10, delta is equal to 10, those are called as downfilled protons, or the signal, we call such signals as downfilled signals. Upfilled signals, the signal is called as upfilled signal or downfilled signal. So those signals which are towards 10, delta 10, they will be called as downfilled signals, and this is called de-shielded protons. So those protons which are de-shielded. Now which protons are de-shielded? Those protons which are which have neighboring groups where there are electron withdrawing groups. Okay, or electronegative atoms are there, like oxygen, chlorine, bromine. If such atoms are present in the neighboring uh, carbon or neighboring surrounding, then, or environment we can say, in the environment if there are electron withdrawing groups like oxygen, electronegative groups, then such protons will be called as de-shielded protons. Okay, now this we can easily understand using examples. The next whatever numericals we are going to solve, they are based on all these d-shielded and shielded protons only, and how the signal looks like. So once again, let us revise this NMR spectrum. I'll just remove this so that we can just understand it once again. Okay, so in NMR spectra, the signals which we get towards the delta is equal to 0, we call such signals as what? Upfilled signals. What they are, such signals are called? They are called upfilled signals. And what does upfilled signal indicate? That the protons are shielded. Shielded, the word shield means protection. So these protons are protected. Okay, whenever you can see the signals which are towards delta is equal to 10, means they are approaching delta is equal to 10, that indicates that the protons are getting de-shielded, means there is no protection for the proton. Okay, and the electrons are easily getting withdrawn from them because of electron withdrawing group like oxygen, bromine, chlorine, and so on. Okay, so let us, I think this is enough. We will see now the examples to understand this in much better way. Okay, so let us take the example of butane and see how the splitting takes place in NMR and what type of spectrum you can see in NMR spectroscopy for butane. So butane, how many number of carbons are there? There are 4 carbons and hydrogens attached to it. Okay, N-butane, that is normal butane. So straight chain butane, 1, 2, 3, 4, 4 carbon and having CH3, CH2, CH2, CH3, that is hydrogens we are the bonds we will be satisfying with the hydrogen. So if I draw the structural formula as you can see on the screen, now the first thing what you have to do is try to identify the protons, different types of proton. Okay, step 1, you can see here, identify different types of proton in butane. So how many protons are there in butane, that we have to first find out. So butane has mainly 2 types of proton or hydrogen environment. If you see butane, because butane, if you try to divide the butane, you will find CH3, then CH2, again CH2 and CH3. So this is a symmetric compound. You can see it is a symmetric compound. If I draw a mirror here, CH2 and CH3 is just a mirror image of the first 2 atoms. So it is mirror image of each other. Okay, the half portion of butane is mirror image of the first one. So the environment of these protons will be exactly the same. So what are the 2 environments which we are going to get? One of CH3, that the proton which are on carbon having 3 protons, and the other methylene, that is CH2. Okay, so one at the ends. So these at the ends will have same environment. How same? Like this carbon is having 3 hydrogens and its neighbor has 2 hydrogens and carbon. Similarly, the first carbon has 3 hydrogens and its neighbor has 2 hydrogen and 2 and the carbon. It is same like if we have a in a building where we stay, normally the buildings are symmetric. So if you are living here, might be there is a house which is just opposite to you, so both of them will be having same surrounding. Okay, that it is exactly the mirror image of each other. Both the flats will be mirror image of each other. So they are having same surrounding. Your house and the house in front of you maybe have means if they are 2 BHK 2 BHK and exactly same type of structure is there, then we can say those structures as mirror image of each other. And then the environment of both the flats will be same, like one will have right hand side the balcony, so the other will have left hand side balcony. Right hand side, if the flat is having a kitchen, then the opposite flat will have left hand side kitchen, and so on. So here you will find that this is just an example to make you understand that how the environment is same for both the protons. Okay, so coming back to our butane, so here in butane, first carbon, it has 3 hydrogens, and neighboring carbon has 2 hydrogens. Similarly, the terminal carbon, that is the fourth carbon, also has 3 hydrogens, and neighboring carbon has 2 hydrogens. So environment for both these first and last carbon is same. Okay, that means the protons are having the same environment. Similarly, for methylene CH2, this CH2, you can see there the neighboring carbon has 3 protons, and this carbon has on the left hand side 2 protons, so 3 and 2. Similarly, if we talk about the second carbon, what it has on the left hand side, it has 3 protons, and right hand side it has 2 protons. So this way, if you try to find out the environment, you will find that in butane, all the protons, there are 2 types of protons basically. So we have labeled them by, if you see here, I've labeled those protons as A. So terminal protons, I've labeled them as A, and the methylene protons, I've labeled them by B. So basically, in this, we have only 2 types of protons, that is labeled by A and B. Okay. With same environment, we will label them with same letters. So most of the times we use small letters like A, B, C, D, and so on. Okay, this is just to indicate the whether the protons are equivalent or non-equivalent. So chemically equivalent, we denote it by same letter. So here there are 2 types of protons we will be getting, which we denoted by A and B. So 2 types of protons means basically in your low resolution we will be finding, okay, we will find only 2 signals. Okay, in low resolution you will find, if the resolution is low, the peaks you will see only two peaks you will see. But in high resolution, those peaks you can find the splittings also, which are shown here. The splittings are shown. Okay, now how this splitting takes place, let us understand. Now we will be applying the rule n+1. So methyl, that is CH3, these CH3, terminal CH3, protons will show what? They are going to show, because it has neighboring, if you see here, this first, let us start from first carbon. So in first, I'll label them first, second, third, and fourth. So first carbon proton, that is CH3, and the fourth carbon. So this CH3 is for first and fourth carbon. Okay, so it's neighboring, both first and fourth has neighboring what? 2 protons. First carbon proton is also having 2 protons. Last carbon proton is also having neighboring 2 protons. So 2, n is equal to 2 for it. Neighboring proton are 2. Okay, for each CH3 group. So according to rule, it will be what? 2 plus 1. So the signal is going to split up into 3 peaks. Okay, suppose this is the peak, it will get split up into, if you see it in the high resolution, you will see it in this way. That is 3 peaks you will find, which is called as triplet. So we will denote this as small t. Okay, this peak we will denote it by small t in bracket. Small t in bracket indicates triplet. Then let us see methylene group, that is carbon number 2 and carbon number 3. So here methylene group, which is indicating carbon C2 and C3. Okay, the protons on C2 and C3. So if you talk about C2, it has a neighboring, how many protons? Just calculate and tell me. 3 and 2. Okay, 3 and 2 total how many? 5 protons. It has 5 protons. So total it will be having 5 protons. So here basically we are here I have shown only one way. So here we should actually have 5 protons. 2 plus here 3 proton, and it's on right hand side there are 2. So 5 plus 1. So you should get 6 peaks. That is 6 peaks indicate septate. Okay, so here you will find the peaks in this fashion. There will be 6 peaks, total 6 peaks. So in low resolution you will have only two signals, but those 2 signals will get split up. The splitting is known as spin-spin coupling. Okay, and depending on how many adjacent protons are present on them. So depending on adjacent protons, they will be split into either if there are two protons, they will split as triplet. If there are five protons, they will be split as multiplet. So here we will write it as M, small m. Okay. So this is how the splitting takes place in NMR, and we can see the signals on the display. So this is how the spectrum will look like on the screen, okay, for NMR spectroscopy. So let us see the next example. Now these are the numericals which we will be seeing one by one. So I think the concept is clear now for everyone. Those who used to say, oh, I don't understand how the splitting takes place, I think I have made it clear. Now if you have any doubt regarding the concept, you can just comment me below so that I can make you understand by only considering that splitting part. Okay, or I can send you some notes in the PDF form. So let us see the first example. Predict the number of signals and the splitting pattern in PMR, that is proton magnetic resonance. They may give you PMR or they may even write it as NMR. Okay, spectra for the following compound. So the compound is 1-bromopropane. So let us write the structure. So if propane, that is 3 carbon, 1, 2 and 3 carbon. Okay, so your 3 carbon, first carbon has bromine, and you can satisfy the other carbon valency by hydrogen. So it is 1-bromopropane. So the first carbon, now let us, first step was what? First step is to find out how many different types of protons are there. Now if you see here, I have written the protons with different letters depending on their surrounding. Now if you see, carbon number 1 I have denoted by C. Carbon number 1 I have denoted by C letter because its surrounding is different. Why surrounding is different? These these two protons are having, in the neighboring carbon there are two protons. This proton has in the neighboring two protons and a bromine. Okay, bromine. Now see, the bromine is electron withdrawing group. Electron withdrawing group. Okay, so these protons, we call these protons as d-shielded protons. What they are called as? D-shielded protons, because they are directly attached with the what? Electron withdrawing group. Okay, now coming to the second carbon. Second carbon, there are two hydrogens. Now these two hydrogens are having what type of environment? On the right hand side it has two hydrogens, on the left hand side it has three hydrogens. So total 5 hydrogens are there for this hydrogen. Okay, so obviously it is having some different environment than the first one, because first carbon was having what? Bromine on the right hand side and left hand side two hydrogen, whereas the second carbon here is having, left hand side it is having CH3, on the right hand side it is having CH2. So the environment for second carbon proton has changed. That's the reason why we have labeled them by B, the next letter. If the environment was same, then we would have labeled it as C only. Okay, C only. But the environment has changed, so we have changed the letter. The letter indicates, when the different letter we are using, it indicates what? The environment has changed. Okay. Now the next last one, third carbon. If you see third carbon, on the left hand side it doesn't have anything. Okay, all three protons are having no surrounding, but on the right hand side it has two protons. So again, what has happened? The environment has changed. Okay, first carbon and second carbon doesn't have the same environment like the third carbon, or vice versa. Third carbon, whatever environment or whatever surrounding it is facing, is not the same like first and second carbon. That's the reason why for 1-bromopropane we will be getting 3 signals. How many signals we can see? We will be having 3 signals. So those 3 signals we can observe in low resolution. Okay, in low resolution we can only see 3 lines in the graph. 3 lines you can see in the graph. That's all. 3 lines. Now how to find out which line will indicate which group, which proton, that I am going to tell you today now in this graph. So your A, that is this one, these A protons, because it's neighboring proton. How many protons are there? 2 protons are there. 2 plus 1 3. So A protons, that is CH3, the third carbon proton, this, let me denote it by these protons, will split up into triplet. Then next is B proton, the middle carbon, that is second carbon. Second carbon proton has total how many? 5 protons. 3 on the left hand side, 2 on the right hand side. So total 5, 5 plus 1 is 6. So 6 will be hextate, or this should be T, hextate. Okay. Here it is hextate or multiplet. So in six peaks you can see for second carbon proton. Then third carbon proton, that is your this carbon, okay, which is denoted by one number, the C carbon, C protons. So for this protons, the neighboring protons are how many? 2 protons are there. So this proton has 2 protons in the neighboring. So 2 protons means 2 plus 1, so triplet. Now these protons will show how split the signal, which will split up into 3 because it is triplet. So let us understand from the graph. I have shown here for low resolution you will have 3 peaks. The peak which is towards delta is equal to 0, which we call upfilled, will be of A, that is this carbon protons, A carbon, A, which indicates CH3 group, okay, which is, this peak is towards the upfield. B proton, that is the middle one, which is CH2, and C again CH2, but that CH2 is attached with the bromine. This proton which are attached to the bromine, and that's the reason why they are towards the upfield. If you see C peak, I have shown it towards the upfield, okay, more towards delta is equal to 0. So delta is equal to, delta is equal to 10, means downfield. So here the C protons will be towards the downfield. This is called downfield. Okay, downfield. Why downfield? These peaks will be, you can see the peaks of C towards downfield because of the bromine atom. Okay, as these protons, CH2 protons, are d-shielded protons. So in the high resolution, the same peaks, the 3 signals, you can see it in this fashion. Okay, triplet, then multiplet and triplet. So this triplet in a very high resolution means, like on the screen of your mobile you try to uh, extra try to find out by giving the increasing the screen. Okay, so similar way, if you see this in the high resolution, you will find the 3 peaks, and that is the triplet. So this indicates for CH3, and dash CH3 we will be writing, that is for A protons, which we will be showing by in a bracket by T. Then this, it is indicating CH2 of B protons, and in the bracket we'll write small m. Then this is for again CH2, and in bracket we'll write T. Okay, so you can have some values also for this, like this carbon CH3, as it is just near to delta is equal to 0, the value of this, when you will get the signals, it may be 1.2, okay, 1.2 ppm, or delta we can write, that is chemical shift 1.2, and so on. So this way you can have the delta values also in the graph or in your spectrum. So I think this is clear to everyone how the splitting takes place in high resolution and low resolution, how many signals we can see for NMR spectrum. Now the next one is second example. It is ethyl methyl ether. What is the example? The example we are going to see is ethyl methyl ether. So ethyl methyl ether, it is CH3, CH2O, CH3. Okay, ethyl and methyl ether. So ethyl methyl ether, you will have to find out first the how many types of protons are there. So as in the answer itself I have written, there are 3 types of proton. First one is, suppose we'll label them as 1, 2 and 3. Okay, so the first carbon will have 3 protons which are having environment. What environment it is having? This protons, these protons are having only in the neighboring 2 protons. Okay, now if you talk about the middle proton, that is which is denoted by B, on the left hand side it has CH3 and on right hand side it has oxygen. Okay, so this B protons are having different environment than the A protons. Then C protons, again on the left hand side it has oxygen and right hand side nothing. So again all the 3 protons are having different environment. That's the reason why we have denoted them by different letters A, B and C. Okay, now let us see. So if there are 3 types of proton, the signal we will be seeing how many? Yes students, how many signals we can see? We will see 3 signals, because 3 types of protons are there, so 3 signals. Now these 3 signals in low NMR, low resolution. Okay, 3 signals we can see in low resolution. Now when high resolution, the splitting we can find, that is because of the neighboring protons. So first proton, that is A protons, has 2 neighboring protons, so the splitting will be 2 plus 1, that is 3, so triplet. So it will find that A protons which were here, because why they are towards the downfield, upfield. A protons we have shown towards delta is equal to 0, upfield. Why? Because its neighboring proton is CH2, no electron withdrawing group. It is there, but it is just next to the CH2. Okay, so it will have more than 1.2 value. These protons also will have more than 1.2 value, because immediately after carbon there is oxygen as a electron withdrawing group. Then let us talk about B protons. B protons, neighboring carbon has 3 protons, on the right hand side it is oxygen, so 0 protons. 3 plus 0 is 3, 3 plus 1 becomes 4, so it is quadrate. So it will show that 4 peaks. Now if you see here in the high resolution spectrum, the 4 peaks are more towards the upfield, more towards the downfield. Okay, this is more towards the downfield because of oxygen atom. So now it is clear to everyone that those protons which are very next to the electron withdrawing group will show the upfield peaks at upfield. Okay, similarly C protons are 0 plus, no proton in the neighboring surrounding, so it is 0 plus 1, that is singlet. Okay, so singlet, so C protons will show only one signal, but the signal, if you see, I have drawn it in the middle of these two. Why middle of these two? Because it is just directly attached with the oxygen. Okay, it is directly attached with the oxygen, so it will again be next to this A protons, not, means after A protons it will be, that is towards the downfield again. So B and C proton signals will show downfield protons and are highly de-shielded because of oxygen atom. So both these protons are highly de-shielded, so they will be showing in the downfield direction. Okay, now let us go to the next one. Next example is your 1-propanol. Okay, 1-propanol, so CH3, CH2, CH2OH. So again, let us see the number of protons. There are 4 types of proton. Now you understood how to find out the number of proton, the first step. So depending on the environment, we can find out the number of protons. So here, how many protons, different types of protons are there? There are 4 different types of proton, which we have labeled it as A, B, C and D. Okay, as A, B, C and D means all the protons which are here are having different environment than each other. Okay, CH3 proton will have different environment than CH2. This CH2 is having different environment than this CH2. Why these two CH2 are having different environment? Because this CH2 is having oxygen on, or OH group on the right hand side, and left hand side it has CH2. So the environment has changed. And last, the D proton, which is directly attached with the electronegative group, that is oxygen. So this proton will be highly de-shielded proton. Okay, this proton we call it as highly de-shielded. So obviously the peak which we will be seeing which will be more towards what? More towards the, so this is your d proton. Okay, more towards the downfield. Now let us see in the low resolution how many signals you are going to get. Obviously 4 signals, because 4 types of protons are there. Okay, and splitting, I think now you are clear. 2 plus 1 3 means triplet it will show. So A protons will show triplet, B protons will show multiplet, because there are 6 peaks which we will be seeing. Then D protons will show only one singlet, and your C protons will show triplet, and this sequence only they will be visible in your spectrum. Okay, A protons, because they are shielded one, so they will be more towards delta is equal to 0. Then little more shielded is your B protons. D is highly de-shielded because of the oxygen, and the C protons will be highly de-shielded because of the two groups. One is oxygen and other is the CH3 CH2 groups, which will be also slightly, they will be having more de-shielding than OH group. Okay, so this way you will see the spectrum or the splitting of NMR for 1-propanol. Now the next one is acetic acid, CH3COOH. Now I think now up till now you are clear with how many different types of protons are there in the molecule. So in CH3COH there are only two types of proton, one is A and other is B. So the signals in low resolution you will be finding two signals of NMR, and if you go to the high resolution, again you are going to see only two signals, because this CH3 is not having any neighboring uh, proton. Because if you write CH3 acetic acid in this fashion, it is this way. Okay, this way, CO. So this proton is having 0 protons in the neighboring carbon. CH3 has 0 protons in the neighboring carbon or neighboring carbon. So this proton will be 0 plus 1, that is one signal which I have shown here, singlet. Similarly this proton, that is OH proton, is also going to show singlet, because its neighboring, that is oxygen, is there. So no proton, that is 0 plus 1 singlet. So in high resolution as well as low resolution, acetic acid is going to show only singlets, that is no splitting. Okay, and two signals we will be seeing in NMR spectra for acetic acid. Now the next example is butanoic acid. So butanoic acid, CH3 CH2 CH2 COH. So if you try to find out the environment and type of protons, there are 4 types of protons: A, B, C and D, as shown in the figure. So if there are 4 types of protons, obviously in the low resolution for NMR spectra we will see 4 signals, and these 4 signals will further split in the high resolution in such way that a splitting takes place in this way. A is going to interact with B. So while interaction, that is spin-spin coupling of A with B, it is going to have 2 plus 1, that is 3. Okay, 2 plus 1 is 3. So here it should be triplet. Then B is going to interact with how many protons? With C protons and A protons. So these protons will be interacting. The spin-spin coupling will be with both left hand side as well as right hand side. That is 2 plus 3 5, 5 plus 1 6. So it is sectet or multiplet we call. Then C protons will be, it is having a coupling with only B protons, that is 2 protons, 2 plus 1 triplet. So the splitting will be triplet. And last one, D proton, which is directly attached with the acid group. So it will have 0 plus 1, that is singlet. And as you can see here, D and C proton signals will show downfield, as they are directly attached with the carboxylic acid oxygen. So they will be de-shielded protons, they will be known as de-shielded protons. So their signals will be more towards the left hand side, that is towards delta is equal to 10, and which we called it as highly de-shielded protons, and downfield signals we will be getting for D and C. So if you see, D is having the most uh, highly de-shielded because it is directly attached to the oxygen, as well as because this carboxylic acid, if we see, it is attached with the OH, this hydrogen is attached with oxygen electron withdrawing group, and next to oxygen also there is a C double bond O, and we know that C double bond O is highly electron withdrawing oxygen. Okay, the carbonyl oxygen is highly electron withdrawing group. So that's the reason why the D proton, that is OH proton of carboxylic acid, shows the signal very close to delta is equal to 10. Okay, so here the singlet you can see, then C proton which is triplet, that is because of this CH2. Okay, you can write here CH2 group, this is because of OH of carboxylic acid. Then B, these are your CH2 group which is showing multiplet, that is B1, and this is CH3 group which is shielded one, because see the more the CH2 groups, the protons will be shielded one. Okay, so A protons are highly shielded one. That's the reason they are more towards what, your delta is equal to 0. So this way you will find the splitting of NMR spectroscopy for the molecules, organic molecules. Now the next one is 2-propanol. So in 2-propanol there are how many types of protons are there? Let us find out. It is CH3, CH, CH3, OH. So if you see, it is a symmetric molecule. So student, you always try to find out the symmetry. If it is a symmetric molecule, then the atoms which are on, or the protons on both the sides, will be labeled with the same letter. Like here, if you see, this is exactly symmetrical. I can have a axis of symmetry here. So CH3 and CH3, because they both will be having same environment, they are denoted by A. Okay, the same type of means equivalent protons they will be known as. Then the center carbon, which is having one proton, and on the means in front of it, it is having OH, on both the sides it is having CH3, so it is having different environment than the A proton, so it is denoted by B. And obviously the C proton, because it is directly attached with oxygen, so it is having really different environment, which is completely de-shielded because of oxygen. So there are total how many? We can have three types of protons, and three types of protons are labeled as your A, B and C. So you will get three signals in low resolution, whereas the splitting will be taking place with the use of rule n+1. So A protons, these are CH3 group protons, that is methyl group protons, will split up as what? They will split up as CH3 protons here. I think I am not changed it. So A protons will be 1+1. Okay. So here I think I have copied the previous one. It is doublet. 1+1 is 2. It will show doublet. Then B protons. B proton has total how many? 3 plus 3. That is 6. Total is 6. 6 plus 1 will be 7. So it is multiplet. Okay, 7 multiplet. And C protons are how many? 0. Means for this proton, the neighboring is oxygen. No proton is there. So 0 plus 1 singlet. So in this way, you will get a doublet, multiplet and singlet. So doublet for which proton? A protons. A protons will show doublet, and they will be less de-shielded. Sorry, yeah, less de-shielded, that is shielded they are. Then B protons will be multiplet with 7 peaks, and the C proton, which is directly attached with OH, will be de-shielded, so it is more towards the left hand side, and it is showing singlet. So C proton is showing singlet, so there is a single line, or singlet, single sign signal in a high resolution. So this is what, how the splitting signals takes place, or number of signals and splitting takes place in NMR for 2-propanol, or which is also called as isopropyl alcohol. So I think I have solved so many numerical based on NMR spectra, all for spin-spin coupling. Okay, how the peaks we can see in resolution and high resolution we have studied in this. Now these are some of the numericals, or for practice I've given some examples. Now take down the screenshot of this and try to, or pause the video and try to solve each and every molecule and try to find out the NMR splitting in both in low resolution as well as high resolution. Okay, you are going to solve these numericals, because step by step you have to write them, then only you will get full marks. These such type of questions, if it is asked for numericals, they may be asked for 3 marks or 5 marks depending on the question pattern. Okay, so you, if they ask only low resolution, you have to show only in resolution. If they ask you for high resolution also, then you can show both low and high resolution. So these are some numericals. Now you can just solve them and just post it in the comment and tell me whether you have solved all, whether you got the answer for all the 7. Okay, so till then, thank you for watching. You can just excel your exams by watching other videos which are on polymer. I have posted question and answers, then MCQs for polymer. Similarly, I have posted a catalyst and reagent. There are videos on reaction MCQs as well as question and answers. So, and now for spectroscopy, you will find the videos on question answers, MCQs, and numerical. So this the today's session was on numericals. Numericals were only for NMR, which we studied today. There are other spectroscopical, means spectroscopy numericals also, like IR, okay, which we will be studying in further videos. IR is there, NMR is there, then combination of these two data we can also find out the structure of the molecule. Okay, this all we will be seeing in the further videos. So stay tuned and subscribe the channel so that you can study the spectroscopy in more detail. Do subscribe and like the channel, and I wish that you share the channel to your friends and ask them to watch the videos. So bye till then. Good, have a good day and happy studying.